Welcome to our unit on gravity. To begin with, I want us to talk about how we came to understand gravity. But first, let's talk about some fun facts. First of all, did you know, no matter how great a distance between two objects, gravity never goes to zero. So the gravitational field around any object extends all the way out to the farthest reaches of the universe. Now that field may be very, very small at that distance, but it's not zero. Earth is round because of gravity. When the Earth was in its liquid molten state, gravity drew all of the matter towards its center, creating a spherical shape. There is no known anti-gravity. Did you know that gravity depends upon location, that the mass of the object determines the strength of the gravitational field? Did you know that the highest known acceleration ever experienced by a person was 46.2 gravities, and that gravity is the weakest of the four universal forces? In order for us to understand how we came to know what we know, let's do a quick trip through history. Remember, this is not a story of gravity, but of the people who helped develop our understanding of it, beginning all the way with the ancient Greeks, going on to Nicholas Copernicus, Johannes Kepler, Galileo Galilei, Isaac Newton, and Albert Einstein. The ancient Greeks developed our first real model of the universe, and that model had to do with the four natural elements: earth, water, fire, and air. And the heaviest, most dense of those had to go in the middle, which means that earth went into the center. This created a model where earth was in the center of the entire universe. Now, this may not seem like it has much to do with gravity, but the Greeks believed that all matter went straight to where it belonged. And since earth was in the middle, it explained why when you dropped something made of earth, it would go towards the center. These ideas were further refined a century or so later by a man called Ptolemy. Ptolemy actually wrote a book called the Almagest, and this book actually became your astronomy textbook for the next 1400 years. Then along came Nicholas Copernicus, who was a Polish priest, born in 1473. Now, Nicholas Copernicus loved looking at and studying the stars. And when he was in the middle of his life, at about the age of 41, he started handing out to his friends these documents that he, talked about as being, they were absolutely anonymous, that defied the laws of, or the understanding of the age, and instead of the Earth, put the sun in the center of the solar system. And he listened to his friends' responses, and in truth, he did not openly publish his theories until literally his deathbed, for fear of church reprisal. But while even after his death, his work was not highly recognized, even from small stones rolling down, an avalanche can come, and we see that coming. You start seeing the rolling of the balls with Galileo Galilei, who was born in 1564, who was an Italian philosopher, artist, and scientist. He was actually, towards the end of his life, studying the earthly effects of gravity, and is considered the father of modern-day physics in that he introduced one of the key concepts that underlies all of physics, and that's the idea of experimentation. One of his most famous experiments is where he took two objects of different mass and dropped them from a high area. Now, the legend has it that it was from the Tower of Pisa, but regardless, he discovered that the acceleration of gravity acting on both of those objects was the same, regardless of whether it was a heavy object or a lighter object, that the acceleration itself was the same. He also did some work looking at the ideas of the Greeks regarding motion. and the idea that all matter was either pulling up or down, but it required a force to move things horizontally, and created what we now refer to as the Galilean ramps, looking at how an object, when dropped down one side of a ramp, will come back up very nearly to its original height, regardless of the length of the ramp or the angle of the slope, and hypothesized that in the absence of anything like friction, what would happen to that object if it never again rose to the same height. Now, these ideas were very foundational for future scientists. Now, while Galileo was studying the effects of gravity on the Earth, a man by the name of Johannes Kepler, who was a German-born scientist, born in 1571, was taking a closer look at Copernicus's model of the solar system. Now, Johannes Kepler was very much a philosopher as well as a scientist, and he loved the idea of the perfect circles. But it did not work out mathematically. In fact, he is known to say, "I was almost driven to madness in calculating this matter. I could not figure out why they would rather go in an elliptical matter rather than a circle." And he says, "Oh, ridiculous me." How many scientists have ever thought that as they are studying and working on a problem, until they find the solution and discover that when it's found, the solution itself was simple? Now, what he ended up discovering were the 3 laws of planetary motion, and these were literally world-changing, in that rather than thinking of planets orbiting in simple circles, he addressed the idea that they orbited in ellipses where one of the foci was the sun. And this explained many of the things that had puzzled scientists up to that point. For example, why it seemed that there were times when planets would travel slower and other times when it seemed that they would travel faster. All of these ideas were brought together in Sir Isaac Newton's laws. Sir Isaac Newton, 1643. Now, we've all heard the story of how Newton discovered gravity by having an apple fall on his head. We know from writings of his friends that he actually told 4 people he was inspired by an apple tree. But what really brought his focus into gravity were discussions that he had with a good friend of his by the name of Robert Hooke. Now, both of them debated hotly on this whole idea of force acting at a distance. Now, they knew that there was a force that pulled objects towards the center of the earth. And Hooke actually said that it varied by distance. In fact, one day he and Sir Isaac Newton traveled to the top of a mountain, and Hooke had a pendulum in his pocket, and so that they could actually study whether there was a difference in how that pendulum swung at the top of the mountain as opposed to down in the valley. Now, once he had established that, he turned it over to Newton because he knew that Newton could figure out the mathematical part that would prove the theory. And as he worked, he had a hard time because in truth no terms actually existed to describe what he was doing. So he invented them. He invented the concept that we refer to as a quantity of matter and called it mass, and talked about a quantity of motion, which is mass and velocity. Now, it is now established, he writes in his Principia, that this force that causes an object to move at a distance is gravity, and we shall call it gravity from here on. Isaac Newton recognized the fact that he did not come up with all of these ideas on his own. He did develop what we call Newton's law of universal gravity, which says that the force acting between 2 objects is directly proportional to their mass and inversely proportional to the square of the distance between these two objects. But he says of his own work, "If I have seen further, it is because I have stood on the shoulders of giants." Sir Isaac Newton's explanation of gravity was really the mainstay in our complete understanding until, in 1905, at the age of 26, a man by the name of Albert Einstein developed an idea that would better explain the effects that we see. He said that space and time were actually the same thing, and that, in truth, the presence of mass caused curves in space-time. Kind of like if you have a mattress stretched and you place a bowling ball on the middle of it, that bowling ball will cause a curve in the surface in which it's placed. And if I were to roll a smaller object toward it, it would be drawn toward that mass that is depressing the surrounding area. Now, in order to really understand this, we need to get into some quantum physics, so we'll talk more on this another day.